Hello everybody and welcome back, and now let us continue on fixing our reverse shell and server code. So we will start off with server. As I said, we will fix this code a little bit, add some functions here and there, and we will also add two functions, one for sending data and one for receiving data, which will allow us to actually send and receive as much data as we want. As we can see right here, the result equals target receive of 1024 bytes is limited to this. If the target output or answer is bigger than this, it might actually make our program crash. So we want to fix that first of all. For example, for any bigger command such as natstat, this will not fit into 1024 bytes. So let's first start off by actually putting our server function. So we will put this part of the code in our server function. So we can actually make it a little bit prettier. So let's copy this. Copy. Let's go all the way down, since we will specify it down here, and paste the same code. Then right now what we can do is we can actually delete this. So we can delete all of this. Now I know this isn't a pretty code, but trust me, it doesn't really matter as long as it works and as long as it doesn't break. So first thing we want to do is, first of all, separate it from the while loop. Then what we want to do right now is actually make a function. So def server, and then we will put all of this in that function. So creating a socket, then setting socket options, then binding the socket, all of that should be in the same function. We can also print listening for incoming connections, and then we can accept the connection as well, and print target connected. So you will notice that we also use this s variable right here in the other commands as well, or pardon me, not the s variable, we use the target variable in the other commands. So what we want to do is make those variables actually global, so we can use it in any other function we make, or in our while loop as well. If you just specify the variable inside the function, it will only be used in that function and won't be recognized outside of the code of that function. So we need to make those variables to be global. So global s, global IP, since we use IP right here, which is outside of the function, and global target. So target is also something that we use in order to send and receive the output of the command. And right now this should be good for the target, for the server function. If we need to add anything else afterwards, we will add it. Now right now you will notice something wrong, which is how can we actually execute this. So we actually have to call the function in order to execute it. So we will do that with server, and then the open parentheses and close parentheses, which will call this function, which will execute this function, and which will go down to execute the code. But the next code, as you can see right here, is s.close. Or basically, as soon as this program starts, it will go into the while true loop first before doing any of this. So we want to make a function for the while true loop as well. We will call that function shell. So first of all, let's go upwards and let's define that function to be shell. We'll just call it simple, since shell is something that we use to execute the commands, and we tab all of this into our shell functions. Tab it all just once, so it looks good. And this should be it. Now you might notice that we didn't call the shell command, so we have to call it down there. We have to call it after the server command, so we can't actually execute the commands before the target connects back to us. So the server function has to be called first, and then the shell function has to be called right after the server function. So our shell function will run indefinitely until we as an attacker enter the command Q, which will terminate the connection and which will continue outside of the while loop, and will go to the next execution of s.close, which will close the program and the connection. So this should be it. I believe everything is set good. Now you might be asking, why doesn't this execute this? Well, basically once you have a code in a function, machine doesn't read the code, or the Python doesn't read this code in a function until the function gets called. So we have to call it in order to execute this code right here. So what we want to add as well is two functions that will actually make us able to send and receive as much data as we want. So we will code that up, so make space, and let's call that reliable send. So reliable underscore send, and we want to input a data to that function. So reliable send will be our command, which we will input in this function, and then we have to add another library which we will use in order to dump that data and make it send as much bytes as it can. So import JSON is the name of the library that we will use. So just type upwards import JSON, and then in our function what you want to do is JSON underscore data, we'll call it like that, equals JSON dot dumps, which is a function, and then we want to use data in that function. So JSON dot dumps, and then we want to specify data inside the brackets. Then we want to type our regular socket send function, which is target dot send, and we want to send the JSON data underscore data, and this will be our reliable send, which means we can send as much as we want. So let us actually switch all of our target.send with the reliable send. So we can see right here we have the one and only target.send, so we will just delete that and type here reliable underscore send, and then we send the command. So then our command will get put in this function right here, and then the JSON data will take the value of JSON.dumps of our command. Then we will send the JSON data to the target. So right now what we want to do is also code a function that will perform a reliable receive. Now the reason it's called reliable is because it will actually receive as much bytes as the target sends. So let us code that as well. Define, which is the short for function, reliable underscore receive. Now you can call these functions anything you want. I will just call it like this. And right now what we want to do is actually perform a little bit of a bigger code than for the reliable send. In the reliable receive we do not need to specify anything between the brackets, since we are the one that are receiving the results of our command. So we want to specify a local variable called JSON data equals and then the empty string, and we want to run a while true loop in order to actually add the bytes per byte, so 1024 bytes to another 1024 bytes until we run out of bytes. Well, it sounds maybe sounds problematic, but it really isn't. So just type here a while true loop, which is an infinite loop, and we want to perform something that we used before, which is the try and accept rule. So it will try something, accept when it receives an error, and we will use that error in order to continue. So let's try to code this. So try, this should work, try JSON underscore data equals JSON underscore data plus target dot receive, and we want to receive here 1024 bytes as usual. And then after that we want to return the function JSON loads of our JSON data. And then if that is it, if the JSON data is basically lower than 1024 bytes, it will return it, except it will give us a value error. Now I already checked this, so I know that the name of the error will be value error, so I just type it right here, except value error, 2 dots, and then continue. Why do we specify here continue? Well, basically if we get a value error, it means that the data that the target sent was larger than 1024 bytes, which means we need to go back to the while true loop, and then it will perform the receiving on 1024 bytes once again, and it will add it to our variable JSON data, which also has the previous 1024 bytes, and it will do that as long as there is some bytes left to receive, and as soon as the bytes are no longer left to receive, it will just quit right here, and it will send us back all of the bytes that the target sent. So these are two functions used to send and receive as much data as we want. But right now, since we coded the reliable receive, we want to change this. So result equals, we delete 1024 bytes, since in our function we did not specify anything in the brackets, and result equals reliable receive. So we will get the result right here, and we will print the result. So this should be good, all should be good for now. We have the command equals q is break, else result equals receive reliable receive, and then print the result. Then we go back to the while true loop, and then we get prompted for the same command, which we send with our reliable send command. Good. Let's see down here. We coded a function server, we called the shell function in while true loop, and we also called reliable receive and reliable send function, which we use in our shell loop. Good. So this should be, I believe, it for the server. So let's close it. Now let's, before we close it, actually call two functions, since we will use same functions in our client server, in our client code, which is our reverse shell. So we copy this, we close this, and then we nano the reverse shell.py. Here, let us just paste these two functions right away, and we have to actually change a few things in these functions, since we do not have something called target in our client code. We have to change that into actually sock. So as we can see right here, in our client code we actually send and receive data with sock.receive and sock.send. So we have to change that right here as well. So it's not target.send, it is sock.send. So let's delete this, sock.send, and we send the JSON data, and here we have to type here sock.receive, since that is what we specified in our client code. Good, so we have the functions ready. All we have to do right now is actually use them in our while true loop. So sock.receive we do not longer need that, we only need reliable.receive. And we delete the 1024 bytes. Then right here, once we send the result, we do not need to sock.send, we can use reliable_send, and we send the result. But right here, let's also run a simple function so this code looks a little bit prettier. What we want to do is, let's actually create down here. What we want to do is also on our while true loop create a shell function. So while true will be put in a shell function, define shell, we will call it same as in our server code, and all we have to do is just tab all of our code. So tab this, tab this, tab this, tab, and just do same with all of these code. Now that we have a shell function, we have to call it, but before we call it, we actually have to perform the connection. So let's actually copy this upper code below all of these functions right here. So copy this, then we can delete this, and we'll paste it at the end of our code. So it actually goes through all of our functions before executing that code. And we paste it right here. So we paste the same code as it was upper. So let's see if this will work. Sock equals socket.socket, socket.tfi.net. Okay, we connect, we print connection established to server, and then we can run our shell from here. And then we enter the while true loop, which makes us execute the commands on target PC. So we have the reliable send and reliable receive function, and right now I believe we should be good to go. But before we actually save this program and run it, let's run a simple try and accept rule for executing the command on target server or on target machine. So right here, this is the part of the code where we actually execute the command that we get from the server and send the result back to the server. Here we want to run a simple try and accept rule for the commands that can be run. So try, we want to try to execute the command, we want to try to do all of this and then send the command back to us, and then accept So for every time a command can't be executed for some reason on target machine, we want to make and try and accept rule so our code doesn't break. So for every command that can be run, we want to reliable send or send to our target machine, reliable underscore send, open brackets, let's make it like this, can't execute that command. We can do it like this, or we can put this string in a variable and then prompt it to the reliable send. But we can also do it simply like this, just by sending a string to our reliable send function. It is the same as if we actually took this string, put it in a variable, and then printed and then put the variable between these brackets. So this should work, if you ask me. For now on, let us just save this right here. Exit, and then let's first of all check out the server before we run it. We have the reliable send, the shell function, the server function, okay, and let's run the server. Right now we are listening for the incoming connections, so let's open another window, view, zoom in, oops, let's put this so we can see both of the windows. Let's go to the Python reverse, and then we run, or let's clear the screen first, and then we run the reverse shell.py. So the connection established well right now, so we know that on our server the connection or the server function was executed, and we went into our shell function which prompted us for executing command. So let's type here ls, and something right here doesn't work, so let's see what. Here we can have, oh yes, in our reverse shell, of course, we didn't import the JSON library, so let's close this. We do not need this terminal. In order for us to use these functions right here, as we did in the server code, we need to import the JSON library, so we can use these functions, json.dumps, json.load, loads right here. We need to have that library so we can use those functions, otherwise that our code will not recognize them. So import JSON, then let's save this once again, close this, let's open another terminal, enlarge this right here, view, zoom in, make this a little bit smaller, go to the Python and reverse, run our server once again, run our reverse shell, and then execute ls command. So we can see we successfully executed our reliable send and reliable receive commands. So everything works perfectly for now. So let's see who am I, and what if I type here ansted.ntp, for example. We get everything right here, clear. It clears the screen, since we actually cleared the screen of our terminal. Who am I, pwd, I don't know, we can try ifconfig. So we get output of all of these commands back to us. Also, if we type here enter, as you can see right now, it doesn't actually hang on the code, and we can still execute the command. So if I type who am I, we can still get the result of the commands. That's because we implemented that try and accept rule on executing the command. It tried executing nothing as a command, and it didn't work, so it actually skipped right to it. So we can try executing something that doesn't exist, or let me just see, so we can get prompted can't execute that command. Let's see dir. Okay, so dir works as well right here. Well, I believe we will get to that sometimes. It doesn't really matter. What matters is that our code now works. We can execute all of the commands. We can just print out PS to list running processes. We can print working directory. We can do anything we want. We can create directories, so mkdir test, and if we type here ls once again, we can see there is another directory right now called test in our file folder. So that's good to know. Now let's see if the Q option works as well. So we type here Q, and we can see both programs close without any error, which is good. And right now, if I type here ls, you can see we still have the test directory, so I will just remove it since we don't really need it. And right now we have a working reverse shell and server.py, which can be used to execute system commands on target. But there are still some things that don't work here, such as changing our directory. For example, if I try to change my directory, I won't be able to. We will see how we can actually fix that as well, and then we will start adding some more functions and some more available things for our reverse shell. So that would be about it for this video. I hope you enjoyed it, and I hope I see you in the next one. Bye. Hello everybody and welcome back. And in the previous video we fixed some of our code bugs that we had, and we also added some of the functions in order to perform the action of receiving and sending packets a little bit more efficient. So right now, as we saw in the previous video, right now we can send packets of any size and we can receive packets of any size. So right now, since we finished the first part of our beginner shell, basically we just finished the executing commands part, we can actually try to test out the shell itself on the target system. If all works well, that means we can continue to add different types of functions to our shell, and we can add some of the things such as running at system boot, for example, putting the file in the registry key, self-copying the file, basically screenshotting targets, running keyloggers, and so on and so on. But before we do all of that, we actually have to make sure that our shell works properly. So let me enlarge this terminal. So view, zoom in, and let's go to the Python where my reverse directory is, where we have our reverse shell. So if I nano it, we can see everything that we did for now. We have these two functions for receiving and sending. We have the shell function, which for now on only basically quits the function or the program itself once we specify Q as a message or as a command, or in any other case it will try to execute the command on the target system. If the command can't be executed, it will send this string, can't execute that command. So right now what we want to do is actually run this program on our Windows machine. But we all know, in order for a program to be an executable and to be able to run it to the Windows machine, we have to make the .exe file with this reverse shell. For that we will use the wine and the py installer that we installed in the system hacking section. If you didn't go over that section, make sure to check out the video wine installation, since there I showed how we can install the wine program, which allows us to use Windows programs on Linux systems. There we installed the Python 27 version, and there we also installed the py installer, which we will use to compile this program into .exe version. But before we do all of that, we need to change a few things right here. So you might notice that basically we cannot connect to the 127.0.0.1. Once we run this on a target system, we actually have to specify the IP address of our Kali Linux machine. So let us close this and check out our IP address. So it is .1.9. We take this IP address right here, we can copy it, and right now we need to go to our reverse shell, find the connect function, so here it is, sock.connect, and instead of the localhost IP address we specify our own IP address. This is because the reverse shell will run on a target system, so we need to specify to which IP address the reverse shell should connect to. We specify the IP address of Kali Linux machine, so our target will connect to our Kali Linux machine. Now, keep in mind that this IP address will only work on localhost, so if you were to run this over the internet, this attack, you would need to specify either to port forward this IP address on your router, or to use, for example, ngrok in order to run the attack over the internet. Here you would specify the IP address of ngrok site, and here you would specify the IP address, or pardon me, the port that ngrok has given to you. Now we will do all of that even later on, but for now on let's just do the attack over localhost. I will leave the port to be 54321. So also another thing to make sure is that the port isn't in use on the system, on your Kali Linux system, so keep that in mind as well. And this should be good to go. Now we need to change these things also in our server, so nanoserver.py. In our server we can see we have similar functions, so for sending and receiving data, the shell function which sends the commands to the target system, and the server function which actually performs the connection, or basically performs the listening part of our server. Here we can see that we binded the IP address of localhost in 54321. We need to change the localhost to the IP address of our Kali Linux machine, so just copy paste it right here. Now, if you don't have any programming knowledge, you might be asking why are we pasting the same IP address in both of our programs. Well, basically, the server program is the program that we will run as a listener on our Kali Linux machine. So that is the program that we don't send to anyone, we run it ourselves. And the reverse shell program that we saw previously is the program that we send to the target and that the target executes, and basically that program will perform a connection back to our server. So we need to specify on our server the IP address and local port on which to listen to, which is our IP address and our local port that we choose. And on target we need to specify the connect function to the IP address of our Kali Linux machine, which is the same as here, and to the same local that we chose. So that should be it. We need to save this as well. And all we have to do right now is make sure that we have the root.wine folder right here. If you click here ls, you should make sure to have drive C as well. In the drive C, if we go there, you should go to the Python 27 right here, and in Python 27 you will see a directory called scripts. In that directory there is where we installed our pyinstaller.exe. So change our directory to scripts ls, and here we should be able to find the pyinstaller, which is right here. So if you do not have this pyinstaller right here, as I said previously, make sure to check out the wine installation video that I did in system hacking section. But right now, since we have it, we can compile our program with no problem. So let's go back to our reverse shell directory, so root python files reverse, and all we have to do is compile our reverse shell.py. We do not need to compile the server.py, since the server is something that we will run on Kali Linux machine, and it is already executable for Linux systems. We only need to make an exe version of this shell right here in order to run it on Windows systems. So how we do that? We need to specify the wine right here, since as we said before, the wine is a program that we use to run the Windows programs on Linux. So we need to specify wine, since we will be running the Python for Windows that we downloaded in our wine folder. And we need to specify the path to the pyinstaller, which we will use to compile the program. So the path is root.wine drive C Python 27 scripts and then pyinstaller.exe. You need to specify this path. It should be the same for you. If it is not and you actually installed the program into some other directory, make sure to find that directory, have all of this in there. So have pyinstaller Python 27 under the scripts, and make sure to specify that directory. Now after that we want to specify the name of our file that we want to compile, which in our case is reverseshell.py, and basically this could be it, but we want to specify a few other options that we will use in order to make our program more appropriate for this task. So for example, if you were to run this, it would give you a folder full of files and libraries that need to be used in order to run the .exe version of our reverse shell. But we only want to make the entire program to be one file, so we need to compile the reverse shell into a one file and not a bunch of files. So we will specify the option right here. So specify -- and then one file, just type here with words, so one file. And also when we run the program, we want to not be able to see the console. Now the console is basically the command prompt, so sometimes when you open programs the command prompt will pop up in waiting for some task to finish. We do not want to prompt the user with this window right here, since that would be suspicious. What we want to do is basically user to double click the file and to think that nothing happens. So nothing will be opened once the user runs our reverse shell. So that's what we want to achieve. In order to achieve that, we need to specify -- no console, so that console doesn't pop up, and this should be good. And right now if I click here enter, this should start compiling our reverse shell.py into the reverse shell.exe. So this will take a few seconds, all should be done well, And you might notice that at the end of this compile our program will be significantly bigger. That is because this adds a bunch of other programs as well to it, a bunch of other libraries and all the things it needs in order to make this an executable. And right now we see that our compiling has finished, so it says right here building exe completed successfully. So let us just ls once again. And you will see we get a bunch of different things added to our directory. We get a directory called build, a directory called dist, and also something called reverse_shell.spec. Now, where we want to go is we want to go to the dist directory, so change our directory to dist. Let us clear our screen a little bit and type here ls. And in our dist directory we have our compiled program. This is what we have to deliver to our target. So what you want to do right now is deliver this however you want. I will use my USB drive, so I will just plug it in right here, go to devices, USB, and choose your USB drive right here. In my case this is the Kingston Data Traveler, and I will plug it in. Then it should pop up right here that the USB drive has been plugged in. That's good, so we click the USB drive and I will copy the file with my terminal. So we have the USB drive called Kali Live. I will close it since I don't need that window open, and I will just copy, or I can actually move. Don't need to copy since I don't need the reverse shell exe on my system. Move it to media, root, and then Kali Live. Now if you do not know how to copy this or you do not know the name of your USB drive, most likely if you just after the media/root type tab, it will prompt you with the available options for the ending of that command. Now I just tapped, and since only I have one USB drive plugged in, it basically found it by itself and it's named it Kali Live. So if I move it right here, I move the program there, and now my reverse shell.exe should be on my USB drive. So now what we can do, if I just type here ls, nothing in this directory, now you can remove all of these things that the compiler has made. So we can remove the build -r, we can remove the dist -r. Now remember to use -r for the directories, and the reverse shell we can use without the -r, so just make sure to delete the right one, don't delete the reverse shell.py, delete the reverse shell.spec. And now we should be left with both of these programs that we had even before the compiling of our reverse shell.py. So right now what we want to do is unplug our USB drive and run the file on our Windows machine. So continue without scanning, and we have my reverse shell right here. I will paste it on my desktop. We can see it is .exe. The size of that file is a little bit large, so if I go right here, you can see that the size of the file is 3.45 megabytes, which is kind of large. Not too much, but it's still something. So that could be the only problem with this thing, since it adds the size to the file once the PyInstaller compiles it to the exe. That's why the file becomes so big, but that's something we can't change, so let's not think about that. Let's actually now run the server. So make sure before you actually run before the target runs this, make sure to set up a listener by running our server.py. As we can see, listening for incoming connections, and right now if you send this to the target and target runs it, you can see that nothing really happens right here. There is no window popping up, there is nothing, it basically looks like the program didn't run at all. But if we go to our Kali Linux machine, you can see the target connected. Shell from this IP address, which is the IP address of my Windows 10 machine, which I can show you right now. If I open my command prompt and just type here ipconfig, we can see that the IP address of my Windows 10 machine really is 192.168.1.3. This port right here is the port from where the connection is coming from on the Windows 10 machine. The local port that we listen on was 54321, and this is the port from Windows 10 machine that is sending the packets to us. So right now you will notice if I, for example, type here dir, you can see that I actually get the list of all the files on my Windows 10 desktop. As we can see, they really are there. So here is Handbrake, Kali Linux, Master Ethical Hacking.jpg, Metasploitable, new folder, Record, OWASP, and all of these things that really are on my desktop currently. If you were to, for example, run arp-a, you would get all the ARP tables of our Windows 10 machine, which currently only has the router and my Kali Linux machine in there. If you were to, for example, shut down the PC, it would shut down the Windows 10 PC, including our Kali Linux machine, so we will not do that since there is no point to do that. So we can see that our shell works perfectly. We can, the one thing that we can do, so for example, pwd doesn't work in the Windows 10 environment, so let's just type who am I. We can get the name of the account, so we can see which account are we on. And basically, the one thing that doesn't work, so if you notice, if I just type here dir once again, I'm currently in this directory, but for example, let's say I wanted to go to the one directory back, so I would do that with cd ... And you would see if I type dir once again that I am still in the desktop directory. Now that is something that we have to fix, since we are only for now on able to execute commands in the current directory. We are not able to change the directory to some other folder, or change the directory back one folder or two folders, so basically go to anywhere we want. So we want to make sure to fix that, or not to fix that. There is a command, we need to import the OS library in order to be able to exit, but we will do that in the next videos. For now on, it is good that we actually know that our shell is good and that is running on both Windows and Linux, even after compilation. So that would be about it for this video. Now let's see, before we actually end this video, let's see how the target can close this program. So if they go right here and try to delete this, they will get prompted the action can't be completed because the file is open. So they can delete this file as long as we are on PC, or basically as long as we are performing the connection. As soon as we close the connection, they will be able to delete this file, and they will delete this file. Now, anyone who knows a little bit about computers knows that they can just go to the task manager, find the reverse shell.exe and end the task right there, which basically would terminate our connection right here. So what we want to do is basically copy the file itself and make it also persistent, and make a registry key for the file that we copied, so it can run every time a target system boots up. So we will be looking at that as well, because right now if the target knew how to open the task manager and found the reverse shell, they would just go to the end task and they would end the reverse shell itself. So that is another thing we have to take a look at, so we can actually have a usable shell and not something that the target can close anytime they want. So if I just type here Q, we should be able to see that the target and the target communication or connection and the server connection has been terminated. So right now, if we just delete this, we can delete the file since we closed the connection. So we will see how we can fix all of that, and that will be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back. And in the previous video we actually tested out our reverse shell in order to see if all of the current functions and all of the current responsibilities of our reverse shell work on our Windows 10 machine. So we managed to compile it successfully with our pyinstaller.exe on our Kali Linux, and we ran it on our Windows 10 machine. Now there are a few things that you might have noticed that actually didn't work. For example, let me just go to my directory with the reverse shell, and let me enlarge this a little bit so we will zoom in. And if I nano the reverse shell, you will see that we didn't code anywhere, for example, that the reverse shell should try to connect back to us every 30 seconds, for example. So let's say we were a little bit late on with our listener, so we didn't set up listener on time, and let's say target clicked the virus or our reverse shell or backdoor, or however you want to call it, before we actually set up a listener. That would make us not be able to connect to them or them to connect to us, since we didn't listen on our local host, on our local port. So we want to actually change that. We do not want the target to actually run the code and run our backdoor, and for them to not to connect back to our server just because we didn't set up a listener. So let's add a function right here. We'll put it right here. So let's add a little bit of space and let's call it connection. The function will not take any arguments, so just type here the connection and empty brackets. And what we want to do right now is basically try to perform the connection every 20 or 30 seconds, or for example however long you want it to be, or for example at any period of time you want to make it. So first of all, let us go to the part where we actually perform the connection for now on, which is this part right here. So the first thing that our code does is basically it sets up a socket with the IPv4 and TCP, and then it performs the connection. After it performs the connection, it prints connection established to server. Now, first thing we want to do is we want to delete the connection established to server, since we are running this on a target and there really shouldn't be anything to be printed out on the target system. So let's delete this, print connection to server. And if you notice right here, right after we connect, we go into our shell function, which is a while true loop, which basically performs actions forever until we specify Q, and then we actually break out of the while loop and break out of our program. So we can actually try to make something similar for our connection, just without the breaking part. So what we want to do is basically, as soon as the target double clicks our code, we want to make it try to connect to our server every 30 seconds, for example. So what we want to do is this function right here, which is sock.connect, we want to paste it in our connection function. So we want to delete this. And basically what we want to do right here is add a tab button. And then, so we added a tab button so it actually belongs to the connection function, and then we want to type while true, which means the same as in the shell function, where that this will perform forever. And while true, we want to actually use a try and accept rule. So we will just type here try and accept. And in the try, we will try to perform the connection. So sock.connect. We want to connect to our IP address, which I need to check out what it is. So let me just open up another terminal. And let me just type here ifconfig, and we can see my IP address is .1.9. Good. So we will try to perform the connection on our 192.168.1.9, which is our Cal Linux machine. We need to put this under the double quotes, and we need to specify a port, the same port from our server as well, the same port that we're listening on, so 54321. We close the double brackets, and this is basically it for the connection. We want to type in the try and accept rule. And after that, for the accept, what we want to do is we basically want to call our connection function inside the connection function. Now, I will explain what this means. Basically, if I just type here connection, this will mean that the function where once the function is called down here, it will go through this code, it will go to the while true loop, it will try to connect, and if it can't connect, it will call itself. Then it will go back to the connection, it will try to connect, then it will go back, it will try to connect, and it will perform the connection function forever until we are able to connect back to our server. So what we want to do is not actually perform this right away. We want to add a timeout for the connection function. So we will just import a library called time. So just type here import time. And time allows us to basically pause our program or put our program to sleep for a certain amount of time. In our case, we will specify that time to be, for example, 20 seconds. So let's go to our connection. After the while true loop, we want to type here Before the try and except, let's type here time.sleep, which is basically referring to this library, and .sleep is just sleep is a function that is specified in the time library. And all we have to do is specify in the open brackets the time that we want to put our program to sleep. If you just specify like this 20, this will mean our program or our backdoor will sleep for 20 seconds and then it will perform the next step of the program. So, one more thing we want to do is what happens if we manage to connect. So if this manages to connect, we want to perform the shell function. So we want to enter our shell. And this means two things. One of them is that we want to delete the shell function right here. And we want to specify instead of the shell function, connection function. So I believe this should be it. I believe this will work. So let's see what actually will happen. So we create our socket, we call the connection function, which will go to this code right here. It will enter the while true loop, it will sleep for 20 seconds, then it will try to connect to our server. If it manages to connect, it will call the shell function, which will enter us in our command execution part, which is right here. If it doesn't connect, it will call the function again and it will go back to the beginning. And it will again sleep 20 seconds, try to connect. If it can connect at that time as well, it will call the function again. So this will perform forever until the target manages to connect back to our server. So we want to save this, so Control O. I believe this will work. We will test it out right now. So everything is good. We call the connection function and we call the shell function from the connection function. Okay, so say once again, Control X to exit. And now let us actually try to compile this and see if this works. So what we will do is we will first compile it, then we will actually run our reverse shell first instead of the listener, and then after, for example, 20 to 30 seconds, we will run our listener to see if this works. So let's see what, let's first compile the program. So what we want to do is type here whine/root. Now we perform the same compilation as in the previous video. So drive C, Python 27, and then what we want to use is the scripts library and pyinstaller.exe. After that we want to specify the name of our file, which is reverseshell.py. And we want to also specify it to be one file and without console. We do that with these two commands, which is --one file and --no console. Then we press enter and let this compile. This will perform the compilation with our pyinstaller, and then we will be able to transfer it to our target with our USB drive or however you want it. So I will just plug in my USB drive. And right now what I will do is, first of all, I will put it to be on our virtual machine, so King Data Traveler. Now when it is plugged in, I will copy the file to our USB drive. So first of all, we go to this directory as in the previous video, we list, and we move the reverseshell.exe to media, root, and then my Kali live USB drive. Once we move it, I can now eject the USB drive right here, and I can call my function from here, or pardon me, my backdoor. So I will paste it on my terminal, on my desktop, and I will double click it so it will run. Once it runs, I will wait for a few seconds, and then I will actually try to run my server and see if it will connect back to us after we actually run it on target system. So first of all, while we do that, let us delete the unnecessary directories, which is the dist, we do not need it anymore, the build, and the reverseshell.spec. We can delete all of those. And right now, if we check out if everything is okay with the server, so we didn't change here anything, it listens on the correct IP address and on the correct port. And now if we try to run the server, We run it, it says listening for incoming connections, and we can see our target has connected, even after we running it on target PC. If we type here who am I, we can see we get the account. If we type here dir, we get all the files on our desktop. So now we got a way that we can actually connect to our target whenever we want. If they run the backdoor, for example, 3 hours ago, and we run our listener 3 hours later, we will still be able to connect to the target system, since they are constantly performing the connection function from socket library every 20 seconds. So that would be about it for this video. What we will do in the next video is we will see how we can also make this program run even after the target reboots their system. So right now, for example, we can connect at any point after the target runs the program, but if they shut down their PC and they restart it, the program will not be running anymore. So what we can do is, if they reboot the PC, we will not be able to connect anymore to the target until they run the program once again. So we want to bypass that as well, and we will do that in the next video. So hope you enjoyed this one, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now let us see how we can perform the persistence function or persistence option for our reverse shell. So first of all, let me just exit the shell from our previous video. We have our shell right here. We can delete this shell since we will use another one after we compile it. Let me just delete this. Okay, it doesn't want to delete yet, so we will delete it in just a few seconds. And right now what we want to do is we want to nano our reverse.shell, or pardon me, reverse_shell.py. Here we have everything we need for now on, and what we want to do right now is code the part where we will actually perform the persistent on target system. Now, before we do that, I want to introduce you to a certain part of Windows called the registry. Now, you can enter the registry in Windows by going to the search bar, typing in run, opening the run application, and typing in the run application regedit. Once you click on the regedit, you can click OK. It will prompt you for an administrator password since you're entering the registry editor. If you just specify yes, it will open up your registry. As we can see, the registry is basically the heart of Windows. Here we can actually create a registry key which will actually run our target, or pardon me, our backdoor on target every time the target boots up. So what we want to do is go to the, first of all, let me just put this is something that you will probably see once you open the registry for the first time. So we can see these 5 registry directories. We are currently interested in these 2 right here. One of them is the HKey current user and the other one is HKey local machine. Now, they both will be performing the same function for us. If we go to the HKey current user and make a registry key for our backdoor in that part, it will only run after the restart if the user logs into the same account. Now, if we copy it in the HKey local machine, it will run our backdoor no matter on which account the user logs in. For now on, since our target will run this on user account and we do not have the administrator privileges, even if we add the function to copy the or to make the registry key for our backdoor in the HKey local machine, we will not be able to do it since it requires administrative privileges. We can only make the persistence at the moment for our HKey current user. That means we can only make the persistence after the user logs in to the same account. So we will do that for now. If you go to the HKey current user, press on the arrow right here, go to the software. As we can see, you find the software right here. Press on the arrow down there, find the Microsoft, press there the arrow as well, scroll down, and what you want to find is the Windows, and in the Windows you want to find the current version. So let me just show you how that looks like. So you found the Microsoft, you pressed on the arrow, scroll down, found Windows, right here, found current version, and you want to find the run folder. Here all the registry keys are here for the files or programs that will run at the startup of the user login. So we can see we already have some such as CC Cleaner, OneDrive, Steam, and other default applications that most of us have on our PC. Now this is also some part of the PC where most of the viruses and backdoors will be if you have one. And this is also where we will actually install the registry key for our own backdoor. But we want to perform a smart thing, which is actually copying our backdoor first to some other directory where the user won't find it, and then putting the registry key to run the backdoor from that other directory. So for example, if the target closes our backdoor in the task manager, they can then delete the file simply. Now I'm not really sure why right now, probably because they didn't close it good. So let me just open my task manager so I can delete this reverse shell. Seems like the process is already running for some reason, which I'm not really sure why, but it doesn't really matter. We will just find it right here, close the ending the task of it, and then we can now delete it. And this is how the user will also be able to delete it. So we want to make sure to copy the reverse shell right after they run it into some different directory, and then we want to create the registry key for that different directory. As you can see, the registry key is something like this. You perform the name and it will set the path to the program that you want to run. So for this program, for example, the path is C, program files, Gyazo, and then gystation.exe. This is the program that will run at startup every time I log into my Windows 10 account. So let's see how we can perform that. First of all, we will want to implement two different libraries for Python. One of them is the OS library, which we will use for multiple things later on, and one of them is the sys library. Now, I will show you how you can perform all of that in the next video. For now on, I just wanted to explain what we will be doing, so that in the next video, when we actually code all of this, you don't get confused by what am I doing. So I will also explain in the next video every step I do, what exactly that means. So I hope I see you in the next video, and take care. Bye.